welcome to Department of Chemistry. Myself Patil Jayashree. Today we see the remaining part of spectrophotometry. In that we focused on single beam photoelectric colorimeter. Okay, the basic component of the single beam colorimeter is a source of light such as a tungsten filament lamp along with a concave refractor and collimating lens. Second component is adjustable diaphragm, or it is also called as a slit. Then next is colored glass for a monochromatic light, that is filter. Then a cuvette which is used for sample holding. Next is detector. Here we are using a photovoltaic cell as a detector. And the last one is the recorder such as a galvanometer. Okay, an assembly of this component is shown in this particular figure. Polychromatic light from a tungsten lamp is reflected by a concave mirror in a direction of a filter. Also, the light passes through the collimating lens. The collimating lens makes the beam of light parallel. Function of collimating lens is what? To make the beam of light parallel. Okay, the light passes further through the slit number 1, which controls the ongoing light. The filter converts the polychromatic light to a narrow bandwidth wavelength of light, that is nothing but the monochromatic light. It passes further through the absorbing material, where the material absorbs the part of the depending color depending upon the color intensity of the solution. Means how much amount of wavelength of light get absorbed is depend upon what color density of the solution, and transmit the remaining intensity through the slit number 2 towards the detector. What is the function of detector? Detector converts the light energy into the electrical energy and feeds it to the recorder. The signal magnitude of the recorder is then measured as the form of absorbance or transmittance of the solution. Generally, the experimental procedure for the single beam colorimeter is first is determination of or selection of the lambda max, means at which particular lambda max the absorption or transmittance is maximum. That the wavelength of lambda is selected throughout the procedure. Then next is cuvette is filled with the solution or solvent, and 100% transmittance is zero absorbance is obtained with the help of variable slit 1. First of all, we have to adjust the transmittance at 100% or absorbance at 0. For that purpose, we are considering a blank solution which is placed into the cuvette. Next is the match cuvette or same cuvette is then filled with the solution of which we are going to determine the transmittance or absorbance of the solution. Okay, deflection in the calibration meter with respect to the absorbance or 100% transmittance gives the absorbance of the solution which is analyzed. Single beam instrument have a disadvantage that here incident radiant power suffers the variation due to the fluctuation in the voltage supplied to the source. To overcome this problem, we have to use the storage battery or use the constant voltage transformer to supply the constant current. So for this, we are using a 2 photocell in a double beam circuit. So here, in place of single beam colorimeter, the double beam colorimeter is very advantageous over to determine the absorbance and transmittance of a solution. Let us begin with the single beam spectrophotometer. When a spectrophotometer or photometer are coupled, we get a spectrophotometer. The name itself indicates that there is two types. First is spectro and second one is the photometer. The spectrometer resolves the polychromatic light into its different component of the wavelength and provides any particular wavelength for the desired study. When the spectrometer acts as a part of spectrophotometer, it is called as a monochromator. Here we are using a spectrophotometer as a monochromator. The photometer is an instrument which is used to measure the radiant power of the light, and the spectrophotometer is an instrument used to measure the absorbance or transmittance of a solution as a function of a wavelength. The single beam spectrophotometer are particularly suitable for the quantitative analysis that involves an absorbance measurement at a single wavelength in both visible always as well as UV radiation or UV region. A very widely used spectrophotometer primarily in the region of the 340 to 625 for a visible length. Okay, and its range can be extended to 950 nanometer by the use of red sensitive photo tube red transmitting filter. Generally, this representation of the spectrophotometer is shown into this particular figure. Here we are using a vacuum phototube for a radiating detector. Then the signal from the detector is amplified and the meter is the bridge circuit is graduated in a linear scale division from the 0 to 100% transmittance as well as in the non-linear absorbance unit. Here we are using a linear scale, also a non-linear scale. The rotation of the grating drum turns the grating which gives the radiation of the various wavelength. During the measurement, three controls are generally necessary: wavelength adjustment, zero adjustment, and 100% adjustment. Wavelength adjustment, that is the highest lambda max, zero adjustment for the absorbance, and 100% adjustment is for the transmittance for the better result. This spectrophotometer is an inexpensive and easy to operate for the determination of the absorbance and transmittance. Okay, so this is all about the single beam spectrophotometer. Next is double beam spectrophotometer. In this instrument, the wavelength varies automatically and the instrument records the absorbance as a function of a wavelength. The instrument has a two light beam from the same radiating source that is already seen in the figure. One from the sample and other for the blank or reference. Generally, one part of the monochromatic beam is made to pass the sample solution and then fall on the working photo cell. The other part of the monochromatic beam is made to pass through the blank solution or reference solution and then fall on the reference photo cell. There are two types of photo cell we are using here. First one is the working photo cell and second one is the reference photo cell. The two photocells are connected to the comparison circuit which is shown into the figure, and the comparison circuit reads directly the absorbance of a solution. This system is fully automatic. Generally, the double beam spectrophotometer is very simple and very sensitive as compared to that of the single beam. Therefore, we are generally use a double beam spectrophotometer. Advantages of the spectrophotometer is the instrument automatically compensates from absorbance by a blank solution. Next is the continuous replacement of the blank with the sample is not necessary because it is already present into the double beam spectrophotometer. Since two beams of the same radiant power are used here, the time for the sample and reference and two identical balanced photocell are used, and reading are independent of the fluctuation in the main power supply. Since the null method is used for the measurement, the instrument reading are not affected by the variation in the sensitivity of the photocell. It provides a rapid scanning over a wide range of the wavelength and use of recorder. The instrument is very useful for the quantitative analysis in which the total spectrum is required. So, double beam spectrophotometer is more useful as compared to that of a single beam spectrophotometer for the determination of the absorbance or transmittance of a solution. Now, we are consider the next part of the spectrophotometer is spectrophotometric titration. So what is spectrophotometric titration? The titration in which absorbance of a solution is used to determine the endpoint are called as spectrophotometric titration. Means here we are using a absorbance for the determination of the endpoint. Such a titration are called as the spectrophotometric titration. Let us begin with the instrumentation of the spectrophotometric titration. Both the and filter photometer and spectrophotometer can be used for the photometric titration. The titration those are carried with the help of the spectrophotometer are called as the spectrophotometric titration. These carried with the photometer are called as photometric, or those which carries with spectrometer are called as spectrometer. Okay, here we are using the both the spectrophotometer as well as spectrometer as well as photometer, and therefore it is called as a spectrophotometric titration. Generally, the spectrophotometer are modified to insert the titration vessel or cell in the light path, or a special titration cell is used. Since Beer's law is obeyed for the monochromatic radiation, and spectrophotometer are preferred over a filter photometer for this titration. Okay, then there are generally two methods of photometric titration. In one method, the titration is carried out in the titration flask in the usual laboratory method, or you can see in the from FYBSc you can titrate number of chemicals. Such a method are used here, but here the absorbance is measured by taking the fraction of the titrant from the titration flask and placing the absorptive cell. Of course, the fraction are written completely each time to the titration flask. Through this, it is a simplest method of titration. It is inconvenient for carrying out the titration. In another method, the titration is carried out inside the absorptive cell. If the titration is carried out inside the cell, the modified cell of 5 to 100 ml capacity is used instead of cuvette. This cell is placed in the cell compartment of the photometer or spectrophotometer. The cell is made up of the perspex sheet. Since perspex is not a transparent to the ultraviolet light, two holes are made in the cell to accommodate a circular quartz window that is already seen in your diagram. Okay, these two windows are fitted in such a way that beam of light pass through their center to the photoelectric cell. The cell has two small holes, one for introducing the tip of the microburette and other for introducing the micro stirrer. At the top we can see that there is micro stirrer and another is microburette. Then the whole arrangement of the cell except the window is generally covered with a black paper. Okay, let us begin with the techniques. What is the exact technique? The technique of the spectrophotometer, the absorbance measurement is made at a fixed wavelength, and first optimum wavelength is selected and zero adjustment is get made. The solution is to be titrated is then taken in the cell, and then cell is kept in the beam of light in the instrument. A known volume of titrant is added to the stirrer solution in the cell. Thus, the absorbance of the titrant solution is measured. After each addition of the titrant, the end point of the titration is detected. For this, the absorbance is plotted against the volume of the titrant added. We can easily find out the unknown concentration. Then next, for this purpose we are using different type of method. First one is the dilution correction method, and second one is the selection of the wavelength. Let us begin with the dilution correction method. According to the Beer's law, you know the Beer's law, A is equal to epsilon into B into C. Absorbance is proportional to the concentration of the solution, and concentration in turns depend upon the dilution of the solution. Therefore the effect of the dilution must be taken into account for the absorbance measurement. How much amount of dilution is there, it is effect on the absorbance. The effect of dilution can be made negligible by either of the two following method. For this purpose we are consider In first method, the concentration of the titrant solution is very large as compared to that of the titrant solution. Here we are putting the concentration of titrant solution large as compared to that of titrant solution. In this case, the volume of the added titrant is negligible relative to the titrant volume, and the here titrant means what's the solution which is added from the burette, and titrant means what, the solution which is placed in your beaker. That is a simple language you have to understand. Then titrant volume and the correction for the dilution effect is not necessary. For this purpose, usually titrant solutions used at least 5 times more concentrated than the titrant solution. Means the solution which is take in the burette is must be 5 times more concentrated as compared to that of the solution which is placed into the beaker. Another method is what, the correction is made by the multiplication of each absorbance value by the correction factor, that is V plus V divided by V. Thus the corrected absorbance is measured by using the expression. The expression given here, A is equal to A dash into bracket V plus V divided by V. Here the A is nothing but the corrected absorbance. A dash is nothing but the observed absorbance. Capital V is nothing but the original titrant volume, and V added titrant volume. Okay. So by this method we can easily find out the absorbance of a solution. Next is selection of the wavelength. A photometric titration is the titrant of the reaction product of the titration absorb radiation in the UV visible region. The absorbance measurement are made at a fixed wavelength to locate the end point of the titration. Here we should take a care so that the other absorbing substance present in the solution should not be absorbed at this wavelength. Okay, generally the absorbance of a radiation is carried out here in the ultraviolet visible region, and you have to take the care only the substance which is analyzed it get absorbed in this particular region and other does not absorb at this particular wavelength. Okay, so for this purpose after titration we are considered the 4 different types of titration curves. Let us begin with the titration curves. Here that in a photometric titration curve we plot a graph of absorbance against the volume of the titrant added. Okay, let us begin with the one by one titration curve. First one is the if only the titrant absorbs strongly, means what, only the reactant get strongly absorbed and other does not. Then we get the left hand side of the diagram. In this particular figure we represented that the type of the titrant in which only the titrant or reactant absorb at a certain wavelength, while the titrant and the reaction product do not absorb. In such a case the absorbance does not change the equivalence point. This is the observed in the titration of the generally para-toluene in butanol with perchloric acid at 290 nanometer. This wavelength is chosen because para-toluene sharply absorbs at this wavelength, whereas perchloric acid has no much more absorbance near about this wavelength. Here during this titration we can select the wavelength of 290 nanometer. Only the reactant get absorbed here and other species does not absorb here. The equivalence point we are consider in this particular diagram. So next is the if only the titrant is get absorbed strongly, means here titrant in this particular type of reaction in which only titrants absorb at certain wavelength while the product does not absorb. There is no change in absorbance at the wavelength where only the titrant absorb up to this wavelength equivalence point. After the equivalence point, accumulation of the titrant increases the absorbance. This is observed in the titration of the arsenic 3 compound with the mixture of bromine and bromate. The absorbance reading are taken a wavelength whereas bromine absorbs. Since the product does not absorb at a given wavelength, the absorbance does not change until arsenic 3 remains in the solution. After the equivalent point, the arsenic is completely consumed and accumulation of the bromine increases the absorbance. Okay, here we are considering the two type of curve. First is only the titrant, that is nothing but the reactant absorb, and second one is only the titrant absorb strongly. So next is the only the reaction product absorb strongly. On the left hand side we are considering the diagram of only the reactant is product is absorbed. A type of titration in which only the reaction product absorbs strongly at a particular wavelength while the titrant and the reactant does not absorb this wavelength. During this course of titration, there is gradual increase in the concentration of the absorbing product. See, in the previous diagram there is change in nature, while in this particular case we are having the different type of nature of the graph. Since it accumulates, the titration proceed, hence the absorbance increases till the equivalent point is get reached. Once the equivalence point get reached, after the absorbance remains constant because nothing is added with the absorb light, and this is observed in the titration of the cupric salt with the EDTA, that is nothing but the ethylene diamine tetraacetic acid. The absorbance measurement are taken at wavelength of 745 nanometer. Only the copper EDTA complex possesses much more greater absorbance compared to the cupric solution. So in the last case we are considering the reactant titrant and the titrant both absorb, but titrant less than reactant. Okay, both the reacting species absorb here, titrant as well as titrant, but only the titrant less absorbed than the titrant, that is nothing but the reactant. So type of titration in which both the species get absorbed at a particular wavelength but the titrant absorb less than the reactant, the product does not absorb and hence there will be decrease in the absorbance at the titration proceed. Moreover, the colored of the analyte get transferred into the colorless product by the colored titrant. After the equivalence point, there is no absorbance due to the reactant because of it is already consumed, and the absorbance increases due to absorbance of the titrant alone. This type of titration curve is generally observed when both the titrant and titrant are colored, but product is colorless. This is a key point. So student, the titration curve is very important from the exam point of view. You have to write the particular graph and their explanation in the exam. So let us begin with the advantages of the photometric titration. The method is used. First advantage is what? This method is used to solution of the lower and higher ionic strength or in non-aqueous solvent. Next advantage is the method can be used to highly colored solution which cannot be determined by the usual visual indicator. The slight change in the color are readily detected by the spectrophotometer and hence endpoint determination is sharp and accurate. Other absorbing species do not interfere with the actual titration because only the change in absorbance are taken into the account and not the absolute value of the absorbance. The titration can be applied to a large number of non-absorbing constituents since only the one absorbance is necessary among the reactant and the titrant or the reaction product. This titration provides more accurate result than the routine analysis because the data from many measurements are brought together in the determination of the endpoint of the titration. So last point is this titration technique is particularly suitable to the titration reaction where a relatively large degree of reaction in completion exists at a equivalence point. So next part related to the spectrophotometry is application of the spectrophotometry. The application of the spectrophotometry is divided into 7 parts. First one is the quantitative analysis. Second one is the spectrophotometric study of the coordination compound. Third one is the determination of instability constant. Fourth one is the determination of pK value of an indicator. Fifth one is structure of organic compound. Sixth one is structure of inorganic compound. And seventh one is the qualitative analysis. From this particular point, in the examination there is direct question is asked on this particular point is write the application of spectrophotometry, or there is some time ask which method is useful for the spectrophotometric study of coordination compound. Out of that, the first two methods are very important, and the next is from the exam point of view more focused is on bathochromic and red shift, hypsochromic shift, that is hyperchromic shift and hypochromic shift. Their definition are most of the time asked. You have to focus on it. The explanation of the application of the spectrophotometry we can discuss in the next lecture. Okay, thank you.